Hello everyone. Our topic for the day is decision tree. As we all know, decision tree is again a supervised learning algorithm. So, talking about the supervised learning algorithm, this technique deals with the labeled data. So, being a supervised learning technique, this decision tree deals with data like categorical data. Say, on at the end of this decision tree, you will be end up arriving the results like true, false, yes, no, whether I'll go for a cricket one day international cricket match or not. So there are two selection attribute selection measures that are termed as information gain and Gini index. Here, just like our association rule, it also talks about the process called pruning, that is removing the unnecessary data. So at the end of this decision tree calculation, decision tree classifier, we will be facing overfitting issues at some cases where that will be resolved using the random forest algorithm. In order to build a tree, this algorithm or this classifier uses the algorithm called CART, that is nothing but classification and regression tree algorithm. Every node in this decision tree is either of a decision node or a leaf node. So talking about the attribute selection measure information gain, it is nothing but the measurement of changes in entropy after the segmentation of a dataset based on an attribute. It calculates how much information a feature provides about a certain class. So according to the value of information gain, we split the node and build the decision tree. So a decision tree algorithm always tries to maximize the value of information gain, and a node or attribute having the highest information gain is split first. So in order to evaluate this parameter called information gain, here is the formula entropy of S minus weighted average of entropy of each feature. So now talking about the entropy, entropy is nothing but the measure of purity or impurity in a given attribute. That is, it talks about the randomness in the data. In order to calculate this entropy for any particular variable S, their minus probability of S into log to the base 2 of probability of yes minus probability of no into log to the base 2 of probability of no. So talking about the Gini index is a measure of impurity or purity while creating a decision tree using the CART algorithm. So whichever attribute that has their Gini index value very lesser will be given higher preference than with the node or attribute that has higher Gini index. So the formula of Gini index is like 1 minus summation of j into probability of j square. So here is a real-time example that talks about or that shows the raw data that is taken into account for around 14 days and their various attribute measures and the outcome, that is whether or not I am playing tennis. So the attributes are like outcome, temperature, outlook, temperature, humidity, and wind. So in order to calculate the information gain, the formula is like entropy of S minus weighted average of entropy of all the available attributes. So in order to calculate the information gain, I'm taking each attribute one after the other. So as I was talking, the first attribute is outlook, and the possible values for output are three, namely sunny, overcast, and rain. So calculating the entropy of overall, that is overall probability, which means the out of those 14 days, how many days I play tennis and how many days I do not play tennis. So out of 14 days, 9 days I play tennis, that is yes. So 9 plus denotes yes, and 5 minus, whereas minus denotes no. So the entropy of S is like minus 9 by 14, that is probability of yes by overall probability, log to the base 2 of 9 by 14, minus probability of no, that is 5 by 14 into log to the base 2 5 by 14, whereas the resultant value is 0.94. Similarly, the probability of sunny out of 14 is 5, whereas I play tennis on 2 sunny days and I do not play tennis on 3 sunny days. So 2 plus and 3 minus. So on calculating the entropy of sunny, I end up receiving the value 0.917. Similarly, out of all the overcast days, on 4 days I play tennis, and on none of the day I'm not playing tennis, and then that is I'm not playing tennis on any day, right? So entropy of S of overcast will be like 0. Similarly, on checking the probability of playing tennis on a rainy day, it is 3, and not playing tennis on a rainy day, it is 2. So entropy of S is like 0.917. Now, we'll move on to the next step, that is calculating the information gain. So the information gain of that particular attribute outlook is entropy of S minus weighted average value of entropy of all the attributes. So here is the formula, a summation of values like sunny, overcast, and rain, and their weighted average into the entropy of each attribute. So on writing the detailed formula, entropy of S minus probability of sunny day is 5 out of 14 days, and into its entropy on a sunny day minus probability of overcast out of 14 days into entropy of an overcast day minus probability of rainy day out of 14 days is 5, so 5 by 14 into entropy of that rainy day. So the information gain for this particular attribute outlook is 0.2464. Now, moving on to the next attribute, that is temperature. So the possible values for temperature is hot, mild, and cold. So on calculating the entropy for all the possible values of temperature is here, mentioned here. I have given it in square boxes. And talking about the information gain, so it is 0.0289, right? So moving on to the next attribute, it is humidity. And just like the previous steps, the possible values of humidity, it is high and normal, only two values. And I'll calculate the entropy for each of these values. And I'll end up calculating the information gain of this particular attribute, humidity. It is 0.1516. Moving on to the next attribute, that is wind. I'll be calculating the entropy of all the possible values, that is strong and weak, and I'll end up calculating the information gain of wind, that is 0.0478. Now, moving on to the information gain that which we have assessed with this given raw data, it is like for gain for outlook variable is 0.2464, temperature it is 0.0289, humidity it is 0.1516, and for wind it is 0.04. So among all these things, the one which has highest information gain is none other than the outlook. So from the given example, I can categorize this outlook in three possible ways, that is sunny day, overcast day, and rainy day. Since this overcast day, I cannot come to a conclusion with sunny and rain. Why? Because I play tennis on 2 days and I do not play tennis on 3 days. So I cannot come to a conclusion here. Whereas on out of all the 4 days, all 4 days I am playing tennis, and none of the day I remain idle. So here it is three days yes and 2 days no. So here I cannot come to or I cannot end up calculating a leaf node. So I'll stop here considering my overcast, and I'll remove this attribute named overlook from my raw data table for these mentioned dates, that is day 3, day 7, day 12, and day 13, 4 days, right? All these 4 days I am playing tennis. Now, I'll prune my data, that is removing the outlook parameter or the outlook attribute. And talking about this sunny day, it is day 1, day 2, day 8, 9, and 11. So I'll construct I'll prune the data in this format only for these 5 days, which I have got here, and I'll reconstruct my table in such a format. So again here the parameters or the attributes are namely temperature, humidity, and wind. And I'll reiterate calculating the information for all the factors. So considering temperature, it is hot, mild, and cold. And on calculating the information, I end up receiving 0.57. And calculating the information gain for humidity, it is again high normal values. On calculating it is, the information gain is like 0.97. And for wind, the information gain is about 0.0192. And now taking all these factors into account, among these three attributes, the one which with higher information gain is none other than this humidity. Now, if I look into the table, so whenever the humidity is high, I do not play tennis. And whenever the humidity is normal, I go play tennis. So on a sunny day, if the humidity is high, I'll not play tennis. And on a sunny day, if the humidity is normal, I'll go play tennis. So this is what is my conclusion here. So I'll again split the humidity into high normal, and I'll end up calculating on which day I play tennis and on which day I do not play tennis. Right? Now, there is one another factor or the attribute value called rain. From here, I'll calculate the information gain only for these 5 days. So taking these 5 days into account and pruning the outlook attribute, this is how my pruned table will look like. And for calculating it for the attribute temp on a rainy day, here is the information gain, that is 0.0192. And calculating it for the attribute wind, it is 0.97. And calculating it for the variable humidity, it is 0.97. And taking the information gain for on a rainy day for the attributes like temp, humidity, and wind, the one which has higher this thing, information gain, is none other than wind. So if you look at the table, on a rainy day, if the wind is weak, I'll go play tennis. And if the on a rainy day, if the wind is strong, I'll do not play tennis. So this is my the decision tree. This is how I'll split my decision tree again. So on a rainy day, if the wind is strong, I'll not play tennis. On a rainy day, if the wind is weak, I'll go play tennis. So this is how you have to in a step-by-step manner build a decision tree. So taking the first raw data, you cannot straight away come to a conclusion. And if you prune it with the help of these three measures, that is information gain and Gini index, you can construct a decision tree in such a format. The thing is, decision tree can be built if the data is voluminously a lesser number, and if you have enough time. If you are expecting faster processing time, or if your data is voluminously big, this decision tree will not be an optimal solution. There are few other techniques which supports uh, uh, doing classification in a faster rate and for voluminously big data that we'll see in the following classes. Thank you for watching. If you're really interested with the video, please go watch my channel Learning on the Go Kavya SP, and please do support by liking, watching, subscribing my channel. Thank you.